Okay, so in this chapter, we're looking at what is MetaSploit. So I've titled it MetaSploit Basics. So first thing is MetaSploit. It is a project that came about from computer security programmers, and it's a computer security project that provides information about security vulnerabilities, and it aids in the penetration testing and IDS signature development. It is a packaged program that has exploits preloaded. It is one of the best sub-projects of the Metasploit framework, and that's a tool for developing and executing exploits and exploit codes against a remote target machine with the purpose of penetration and vulnerability testing, as well as IDS signature development. So what does Metasploit consist of? It consists of several different types of modules, specifically these six: payloads, exploits, posts, nops, auxiliaries, and encoders. So payloads, they are the code that is we're leaving behind on the hacked system. So some people can call them like a listener or a rootkit. In Metasploit, they are referred to as payloads. This is essentially, well, the commands, the shells, what's going to be injected into a target machine, what's going to be left behind. So the payload can be stagged, inline, known-X, passive-X, IPv6, along with a few. So don't get hung up with this payloads just yet. We're going to go more in depth with payloads once we cover our 6 modules. Exploits. And exploits are the shell code that take advantage of a vulnerability or flaw in the system. They're operating system specific and many times service pack specific. And that means they're going to be very specific to certain circumstances. And they're classified by operating system. So Windows exploit will not work on a Linux machine, vice versa. So we can't just go, it's a Windows exploit. We may go, it's a Windows 7 exploit, Windows 7 Service Pack 2 exploit, so forth. Next is posts, and posts are modules that can be used post expiration of a system, meaning afterwards. NOPs are short for non-operations. In an x86 CPU, it's usually indicated by a hex 0x90 code. It simply means do nothing. This can be crucial in creating a buffer overflow. We can view the NOPS options by doing a show command in our MSF console. Auxiliaries include numerous other modules that may not fit in any other category. This can include things like foozers, scanners, DOS attacks, and more. So foozing is the practice of attempting random input into a variable area so that we can break it. If it's expecting 1 and we put 5, what happens? So we can fuzz it some. That way we can see if we can get the system to behave different than what it's supposed to. Encoders is another one. Encoders are modules that enable us to encode our payloads, and this is so that various antiviruses may not be able to see it. Normally we encode several times, just in case our first encoder doesn't encode it properly. Encoding is a way to mask our signatures. So let's go back to payloads. Let's go a little bit more in depth. So there are 8 general types of payloads. So inline. These payloads are a single package of exploits and payloads. They are inherent more stable because of their size, but they're not they can't always be used in small vulnerability memory areas. They're going to be need more memory than other ones. Passive X. This payload is for when a firewall rule restricts outbound traffic. In essence, we use ActiveX through Internet Explorer to hide its outbound traffic and evade the firewall by masking HTTP requests. Interpreter. This is an all-powerful payload that we use the most often. We normally want to have this on a victim system. It works by a DLL injection and resides entirely in memory, leaving no trace of its existence on the hard drive, meaning if the systems reboot and MetaInterpreter doesn't load back into memory, we lose access. So specific commands and scripts developed for it enables us to use it on larger works, and it works on a large variety of victim systems. Victim systems. Staged, these payloads essentially are able to fit into very small spaces, and they create a foothold on the system. Then it pulls the rest of the payload. The remaining 8, NOx. In some CPUs, there's a built-in security feature called DEP, or Data Execution Prevention, normally in Windows. And in Windows, it's referred to as a no exception, or NX command. And the idea is if we allow the security feature is kept from data making its way to the CPU and being executed, the NOx payloads are designed to evade the safety features of modern CPUs. That way they can be encoded in such a way where the CPU may not realize them. IPv6, these are payloads as they imply, are designed to work on IPv6 networks. Reflective DLL injection, these payload modules are injected directly into the target process while it's running in memory, thereby never writing anything to the hard drive, leaving less evidence. ORD, these types of payloads work on nearly all Windows operating systems. They're extremely small, but somewhat unstable. They depend upon loading on ADLL into the exploit process. If you look at MetaSploit's directory, the Linux terminal in Kali, we can see that MetaSploit categories payloads into 3 different key areas. While we just covered 8, most of them are covered in 3. Staged. Again, staged payloads use a tiny stager to fit into a small exploit space. In other words, if the victim system's exploit buffer or other memory areas, it's small and only allows a small amount of code to be executed. That's why we're going to be staging them in a staged area. The last 2 are stagers, and that's again, a stager is a small payload where only jobs fit in a small area. Singles, often referred to an inline payload, and these singles are self-contained units that do not require a stager, and they generally are more stable and preferred, but many times the code is too large for the vulnerable memory area for the victim machine. So we have to kind of figure out which type of module and attack we want to go based off of the memory usage of our targets. And that's MetaSploit in the basic. This becomes more simple the more that we get into MetaSploit, the more labs that we do. But this is a nice brief overview of what MetaSploit is and how it works and how it's organized.